This video covers the Alex topic of the additive property of equality with whole numbers, and this is a property we use to solve equations. So an equation is a statement that two expressions are equal. And in order to solve an equation, which is definitely our goal, we want to find all numbers, called solutions, that make our equation a true statement. So for example, x plus 2 equals 9. Well, what value of x makes this a true statement, right? It's going to be 7, right? 7 plus 2 is 9, right? And this one was pretty straightforward to see. But what if they're not? We're going to definitely need to have some tools in our mathematical toolbox in order to solve these. So when approaching an equation and finding the solution, we need to think of an algebraic expression like a seesaw or a balance, right? We need to keep it balanced. So the golden rule of algebra is do unto both sides as you would do on to one, right? In order to isolate that variable. So we have the additive property, which states this. Let A, B, and C be real numbers. Then if A equals B, then A plus B equals B plus C, and A minus C equals B minus C. And our goal to solve for x is to isolate our x. A joke I like to say in class is we like our x's lonely. So you know you're doing a good job as long as your x is lonely. So let's go ahead and solve problem 1 using this additive property, right? If I have x plus 7 equals 10, if I was to say subtract 7 from both sides, that would keep it balanced, right? Because I've already said that these two sides are equal. So that would give me x equals 3, right? I also could have probably just seen from looking at that, oh yeah, x would be 3, right? But that's one of the steps we're going to use to isolate the variables to move the constant to the other side. For problem 2, I have x plus 3 equals 9, and I'm sure you're like, well, Dr. Miller, x is 6, and you are correct. But let's show that with the additive property. I'm going to subtract 3 from both sides, so I get x equals 6 as my final answer.